This is the first lecture of Math 155. We're going to start with sections 1.1 and 1.2. This is the very basics. Statistics is the study of the procedures for collecting, describing, and drawing conclusions conclusions from data. Right, so collecting the data, describing it, and figuring out what it means. In statistics, we often study populations and samples. A population is the entire collection of individuals being studied. A sample is a subset of the population that contains the individuals, I guess you could just say, being studied. Or I should say maybe contains the individuals just chosen / being studied, right? Yeah, I'll say being studied. Oftentimes we want to understand an aspect of an entire population. If we can understand an aspect of a population, then we know how they behave, we know what they want, we know how they are, etc. But if the population is too large or data collection would be too unwieldy, we can't just collect data from every single individual. Imagine if I wanted to understand things about the entire United States population, 300 million people. Couldn't do it. So we take a sample. So a lot of what we do will be focused on taking samples rather than looking at entire populations. We take a sample, we try to make an inference about the population. So just a couple little quick things about why we don't always take an entire population's data, right? So we take samples of our population, right? So then one question is, how do we take samples, right? Turns out there are a bunch of different ways, some of which are better than others, some of which are easier than others, some of which might be more appropriate in certain situations. So let's consider this guiding example, right? Nutritionist receives a shipment of 1,000 apples, wants to figure out the average weight of an apple, but she can't weigh all 1,000 of them, so she does a sample of 50. So let's think about all the different ways you could take a 50 apple sample, and I'll let you know that in class tomorrow, I'm going to ask you about all the different ways you could sample these apples, and I want you to come up with a sampling technique for every single sample that we learn about. Just a fair warning. The most basic example is called a simple random sample. I might abbreviate it, I or the book might abbreviate it as an SRS. Right? Fixed number of individuals randomly chosen. We typically say simple random sample of size n, right? For some number n, maybe it's 100, or in this case 50, right? We fix the number that we want to sample, and then we sample the many. Now the key thing is you have to truly randomly sample, right? So how would you conduct a simple random sample? Well, you could assign, a random number to each apple, then use a random number generator to choose 50 numbers between 1 and 1,000, right? And those 50 numbers would be the apples you chose, right? Choose those 50 apples. Right? So that's not exactly the easiest thing in the world. I think the concept is pretty basic, but actually doing that, actually enumerating every single apple would be a little bit annoying. Then run the random number generator wouldn't be too bad, but it'd take a little bit of time. Right? So maybe there's an easier way of doing this. Right? So here are two more examples. You can pause the video and read them. Now, what do these samples have in common? Well, one thing you might notice is they're both convenient, and I use that word intentionally, right? Stand outside a concert, pretty easy way to get a sample of 40 people. 8 bricks closest to you, right? A lot easier than trying to randomly sample all of them. But I'm also going to say potentially biased, right? Because perhaps people who go to Taylor Swift concerts, maybe they're more affiliated toward one direction than another. Or maybe not, who knows? Probably grabbing the 8 bricks closest to you, that might be a little bit better, but depending on how things are stacked, maybe there's bias. Who knows? A convenience sample is a sample that is not drawn by a standard sampling method. Right? In particular, you just do it because it's the easiest thing to do. So why did they choose convenience samples? Well, they were just the easiest things to do, right? But which individuals might be typically chosen a convenience sample? Well, perhaps it's the people who most want to respond. It's just the people closest to you, right? The easiest response that you can get is going to be chosen in a convenience sample. That can be good, but it can also be bad. It can lead to something called bias, which we'll study later on. So here, if you want, you can write down what I was saying, but I'll leave this up to you. Here's another example. Suppose a company wants to gauge satisfaction levels of its employees. Men outnumber women 3-1. So what if you simply randomly sample employees? What's going to be the problem with that? I'll let you think about that one. You can pause the video if you'd like. But I'll just say a simple random sample will have roughly 3 times as many men as women, probably. So what's a better way to sample? We'll say take sex into account by choosing an equal number of males and females. Right? Because, for example, if there's an issue at work that maybe the men don't really care about, but maybe the women do, you might not really get that representative sample if you just choose 3 times as many men as women. But if you choose half men and half women, that issue might be more stark. Right? So what did we do there? Well, we took the population of workers and we divided them into groups or strata. So we say a stratified sample is a sample where individuals are first grouped into classes or strata, hence the name, and then each stratum is randomly sampled, right? So maybe you put the 300 men over here, 100 women over there, and you sample 50 from each, for example. And again, I will let you think about that. Another example. You can pause for example 4. Is this a stratified random sample? And the answer is no, because every person in 5 hospitals was chosen. Right? Instead of, for example, some people out of each of the hospitals being chosen. Maybe I'll actually write that down. Okay? So this is what's called a cluster sample. Right? A sample in which individuals are grouped into, well, clusters. And then all individuals in each cluster are sampled. So we can think about the pros and cons of cluster sampling. Right. And here's a cute one. You often see this kind of sample on conveyor belts, right? Soda manufacturer is doing some drink testing, looks at every fifth soda bottle. You might think that's a simple random sample, but it's actually not quite. There's a little bit, it's not truly random, right? Whichever soda bottle you choose first, that determines the next soda bottles that you're going to be sampling. Not that it's not random, it is, but it's not a simple random sample. Because I'll say the first bottle sampled determines the others being sampled, right? If I choose the first bottle, then I'm also going to choose the 6th, the 11th, etc. If I choose the second, then I'm going to choose the 7th, 12th, etc. So this is called a systematic sample. It's a sample based on a pattern. Again, randomly selected, still very legitimate, but it's not a simple random sample. And as always, I will leave the pros and cons to you. Maybe let's do one more sampling example, right? I want to know what the kids these days are listening to, so I say to the class, "What music are you listening to?" And I just record, should be first 5 answers that I hear. What kind of a sample is that? It is a voluntary response sample. Right? The sampled individuals are those who choose to be sampled. Right? And as always, there are pros and cons. Right? Think about it. Think about what's good and bad. And lastly, maybe I should have mentioned at the beginning, but here it is. We've been talking a lot about samples, but remember that we're sampling from a population. A characteristic of a sample is a statistic. So all of these sampling techniques that we're talking about here produce statistics. But if we are able to get information from the entire population, then a characteristic of that population is called a parameter. Now remember, parameters are always preferred to statistics, but usually they're not able to be collected. So we typically want to use a statistic to try to infer what a parameter might be. Right. Now let's go on to the second part right here. Okay. We kind of mentioned this before a little bit, but let's be a little more rigorous. An entity whose data is being collected is an individual. Right. A characteristic of an individual being measured is a variable. Information being collected about the variable is data. And the collection of all data is I would call it a study. Right. So let's take a look at this. I got this one, by the way, from question 58 in the book. Let's just take a look at this. What are the individuals? What are the variables? Well, I'm going to highlight, let's put it this way. Let's put it here. The individuals will be highlighted in yellow. The variables will be highlighted in green. Okay? The individuals are the movies that we're considering, right? These guys. Those are the individuals. That's the variable, right? Movie title is the variable. It varies. The actual individuals are the movies that we're considering. The individuals are the release years. The variable is the release year category, right? That is what varies depending on the movie that was chosen. Okay? And that is the pattern that we're seeing here, right? The individuals are the guys being examined. And the variables are just the, the category altogether. Okay. So, one thing that we consider is qualitative variables, or you could also call this, I guess, categorical data variables, are variable whose data categorized individuals but isn't numerically measured, as opposed to quantitative variables that is numeric, right? Now, I don't know why I have that N there. Get rid of that. Two types of qualitative variables. You have nominal and ordinal. Ordinal variables. Okay? Nominal variables are just names, right, usually. They have no natural ordering. They're just labels. Ordinal variables do have a natural ordering. Since they're both qualitative, neither, I'll just say neither addition or ratio. I shouldn't even say addition, really. I should say, when we're comparing things, we typically look at their differences, nor ratios are meaningful. Right? So in example 1, mark the columns for nominal and ordinal. This right here is nominal. The movie title right here is nominal. Right? It's just the label. So is this guy. So is the studio. Ordinal is the rank. Right? I'll just write rank here, okay? Just to let you know, the book considers this whole thing to be ordinal. But just to be clear, the rank is what's ordinal. The name is nominal, right? So there's that. So the reason that an ordinal variable is not quantitative is that just numerical operations don't mean anything with ordinal data, right? If I come in second place and you come in 7th place, you can say I finished 5 spots ahead of you, but that doesn't mean anything mathematically speaking. It's just items on a list. You don't know anything about our finish times or how we performed or anything. Right? So we don't really consider ordinal data to be qualitative. Right, now there are also 2 subsets of qualitative variables. Interval, kind of rare. Interval variables have the property that the value 0 does not imply 0 quantity. So for this reason, differences are meaningful, but ratios are not. And lastly, ratio level data, or ratio variables, have the property that 0 does imply no quantity. So both differences and ratios are meaningful. So in example 1, for example, the release year This is actually interval level data, right? The years, there isn't a year zero, but even if there were a year zero, it wouldn't mark the beginning of time, right? So this is interval level data. But both ticket sales and running time are ratio level data. And that's much more common. Okay, so just a quick little fact. Dates and temperatures, right, assuming we're not using Kelvin, they're the two most common interval variables, okay? I've never seen interval level data other than dates or temperatures, okay? One last thing I'd like to point out, quantitative data is also divided into discrete and continuous. Continuous variables. A discrete variable has values that can be listed. There may be infinitely many of them, but they can still be listed. While a continuous variable may take on any value within an interval. Right, so for example, if we're considering a discrete and continuous variables here, and I have this example 4, read example 4. You can pause the video. Which variables are discrete or continuous? Well, let's see. Shoe size is definitely discrete, right? It's 1, 2, 3, 4, etc. There's no 1.5 shoe size, right? The population, well, depending on how you look at it, I would also argue that's discrete because, again, you don't have fractions, right? You don't have 2.5 people in Salisbury. But the time it takes to commute to a supermarket is definitely continuous, right? Because time is continuous, right? It could take you 2.5 minutes, 2 minutes, 2 2/3 minutes, etc. Okay? So that's all for today.